Okay, so this is going to be the second of a series of videos where we're discussing the properties of limits. The first video discussed what the properties of the limits were and how you interpret them, how you read the limits. This video is going to be an introduction on how you actually apply those limits. So what we see here on the screen right now are two piecewise functions, function f and function g, and we want to apply those properties to the functions that we're looking at. So here we have a smaller version, and if you're following along with the notes that came along with this lesson, then everything is going to look slightly different on your paper, but you still have the same information. I'm going to go ahead and do the first two for you as a quick example, A and B, and then I'm going to ask you guys to pause the video and try working out the rest of them that you see here with F and G, and just see, are you okay with how the limit rules apply? All work will be shown, so if there's something you're not sure about, you'll be able to make corrections to your own work. But let's go ahead and take a look at this. Looking at A, we're going to say, the way that I would look at this is I would say the limit of function f as x approaches 3 from the right side plus the limit of function g as x approaches from the right side. This is how we expand and interpret the limit notation. So what I'm going to do is I'm going to just find the limit of both of those functions from the right side of 3 and then add them and see what we get. So taking a look at function f, I'm coming from this side up towards where I approach positive 3 from the right side, and I see I'm at a positive 6, so I replace here with a 6. Looking at function g, I'm going to do the same thing. At function g, I'm on this parabolic piece here, and when I come up to where x is 3, I can see y in this case is about a positive 8. So when I add those together, the limit of the sum of g of x and f of x as x approaches 3 from the left or from the right hand side will be a 14. On B, the way that I'm going to expand this out is I would say this is a combination of the coefficient rule and the difference rule. So this is going to be interpreted as saying 3 multiplied by the limit of function f as x approaches 5 minus 2 multiplied to g of x, or not g of x, the limit of g of x as x approaches 5. So we're going to evaluate the limit of function f and function g at 5 and then multiply it by those corresponding numbers and then take the difference of them. So let me clean up the graph a little bit. And let's take a look here. So here we don't have to look from one side to the other side. We're just doing direct substitution. So when x is 5, I can see that y is a 2. So this becomes 3 times 2. And then we say minus the 2. And now I'm going to evaluate function g at 5. So when g is 5, I can see that y is 4. So this becomes 4. So the 3 times 2 is a 6, the negative 2 times the 4 is a negative 8, and when you take the difference of them, we get a negative 2. So this is where I'm going to ask you guys to pause the video and try working out the rest of these on your own and see how you do, and then I will go through and demonstrate the rest of the answers. So go ahead and pause the video now, and when you're ready, hit play. Alright, so hopefully you have all of your answers for the remaining problems associated with these two graphs. Let's go ahead and try to bring down the graph here so we can follow along with C and D. So C says I'm going to again just look at it, this function from the difference function as we approach 5 from the left hand side. So when I do that, function f will give me a 3 and function g will give me a 4, and when I take the difference of those, I get a negative 1. Here, on D, it's a combination of the coefficient rule and the quotient rule. And so I'm going to, in the top, say 3 multiplied by the limit of function x, or function f as you approach negative 7. And I'm going to divide that by the limit of function g as you approach negative 7. So in the top, you get a 3 times 5 and in the bottom we get a 3, so the entire thing simplifies to be a 5. Moving on, here we got the same thing. We have the 4 that's going to get multiplied to the limit of function f and function g as x approaches 3. And in this case, the 4 is given to us. The limit of function f will go to a 6 as x approaches 3. But the limit of function g doesn't exist because it's discontinuous there. We're not looking at it from the left and right side. We're trying to evaluate it. And there's a jump discontinuity there, so it's not going to exist. So as long as one part doesn't exist, the entire limit doesn't exist. For the next one here, we're looking at the power rule. Evaluate function f as you approach -3 on the x-axis, and then square that value. So we get a -6, and we square it, we get a positive 36. And here, let me just bring down the graph so we can kind of keep it in frame. Same thing here for limit of, as we approach 4 for g of x, we're going to evaluate function g as x approaches 4, multiply it by 8, and then take the square root of it. And there we go. So on the left-hand side, I did it just as a square root, but on the right-hand side, I added it as saying that you could also work it out as an exponent. Part H is just the sum rule. Evaluate function f and g as x approaches 3 and add them together. And again, function g does not have a limit as x approaches 3, or I'm sorry, -3, so the limit does not exist on that one. And finally, for j and k down here at the bottom, j, the quotient rule, evaluate function f and g at 6, and we get 0 over 5, so 0 divided by 5 is 0. And here, this is where we're going to do a composite. We're going to evaluate function g at -2, and then we're going to compare it at function f for whatever that output is. So function g, as you approach -2, is going to be a -3, so f of -3 is a -6. Okay, we're going to go ahead and pause the video at this time, or stop this video here, and give you a chance to collect your notes and make sure you're okay with everything. If there's any questions that you see on any of the problems demonstrated, please let me know. And until next time, thanks for watching and take care.